हेलो एंड वेलकम गाइस टू आवर चैनल एलिविएट लैब्स। आपका एक बार फिर स्वागत है कोड शेफ की सीरीज़ के अंदर। जैसा कि हमने लास्ट टाइम दो प्रॉब्लम सॉल्व की थी, आज हम धीरे धीरे अपनी डिफ़िकल्टीज़ को और बढ़ाएंगे। तो पिछली बार हमने 1100 रफली 1100 वाली एक प्रॉब्लम सॉल्व की थी और एक 1200 वाली प्रॉब्लम सॉल्व की थी। तो आज हम वापस से दो और प्रॉब्लम सॉल्व करेंगे आज, जो कि उनसे थोड़ी सी स्लाइटली हायर रेटिंग की है, टू अंडरस्टैंड मोर कंसेप्ट्स। ये भी अभी बेसिक प्रोग्रामिंग के ऊपर ही चल रहा है। सो लाइक कपल ऑफ प्रॉब्लम्स वी विल सॉल्व फॉर बेसिक प्रोग्रामिंग एंड after that we will start with array, linked list and all sort of other things like tree, map, hash map. तो आज की प्रॉब्लम है हमारे पास द टू डिशेस. सो लेट्स स्टार्ट रीडिंग द प्रॉब्लम स्टेटमेंट. So the problem statement says that chef prepared two dishes yesterday and chef had assigned the tastiness T1 and T2 to the first and to the second dish respectively. The tastiness of the dishes can be any integer between 0 and n, both inclusive. Okay. Unfortunately, chef has forgotten the value of T1 and T2 that he had assigned to the dishes. However, he remembers the sum of the tastiness of both the dishes denoted by s. So he remembers the sum, but he does not remember the values, right? So chef wonders what can be the maximum possible absolute difference between the tastiness of the two dishes. So can you help the chef finding the maximum absolute difference? So it is guaranteed that at least one pair T1 T2 exists such that T1 plus T2 is equals to S, and T1 T2 is definitely greater than equals to 0 and less than equals to n. This is the constraint. Okay. In the input format, the first line contains the single integer t, which is our test cases. As you now get the gist, like we are going to solve for t test cases in a single run, and the first and the only line of each test case contains two separate integers n and s denoting the maximum tastiness and the sum of the tastiness of the two dishes respectively. Okay. For each test case, output a single line containing the maximum absolute difference between the tastiness of the two dishes. So in short, basically what we are given is the value of n, and basically we want to find out and we have been given a sum s of two integers, let's say t1 and t2. So we want to find out first how many integers are there which actually, so basically how many pairs are there of t1 and t2 from 0 to n which sum to s, and basically we want to figure out the difference. Okay, and whatsoever is the maximum difference integers, we want to actually output them. So we want to output the maximum difference. We do not have to output the numbers specifically, but their difference. Okay, so let's start with that. Okay, so first line of input is our test case t, so we will take that. Then basically we will have our loop of while t minus minus. Okay, and then basically we are given n and s, right? Two separate integers, correct? So we will, first input is n and then second is s. So we are given n and s. Now we want to find out two integers which actually sum up to s. Okay, so one way could be that you could start a loop, let's say ith loop, and then jth loop, and then basically we will check if I plus j is double equals to s. Then we will keep a maximum variable, right, int max. So this is a very brute force solution that we are trying to implement, and we'll see what are the problems with it. So this is our max. Now our max should be, so I will not call it max, I will call it maximum diff. Okay, so let's take this maximum diff here. We will have max of j minus I comma max maximum diff, right? And this maximum diff is present in algorithm. This max function which we are trying to use, this is present in algorithm. Again, a good thing would be to actually check out c++.com for the implementation of max. Okay, yeah, and basically whatever is our maximum diff, we need to output that. This is our very basic implementation of very brute force way to solve it, that basically we are actually trying to figure out all the T1 and T2s which actually sum up to S and then do it. Okay, let's run this. Okay, so our output is incorrect. Why this is incorrect? Let's check. Okay, so as you can see that we are given the integer between 0 and n and both inclusive, but our loops are basically, the ith loop is running from 0 to n, but it is not including n, and similarly j is not also not including n, right? So basically we will include n in both of our test cases. Okay, so now our solution should be correct, so let's run it again. Okay, so our sample test case passes. This is 141. Now let's submit it. But before watching the submission result, here is a quick question. Do you think that this solution is going to give you a perfect answer? This is a fun question to think about. So look at the constraints. Look at what the constraints this problem has given you. Look at all the look at the implementation, look at the time complexity, the space complexity, and think about whether this would work or not. Okay, so for those who think that this will not work, yes, you are correct, because it is showing that time limit exceeded. So if you look at the problem down in more info, you will see that there is a time limit for this particular problem, and that has been set as 0.5 second. And as you can see, as we exceeded 0.5 second, CodeChef has actually declined the output, and it's saying that basically even though your solution was correct at some places, but for some of the inputs it actually failed to get the output in the given time, right? So what we should do? So the idea is that basically we are given 0 to n and we just want to find out the number s. Okay, so if we assume that I is already in, let's assume that I, whatever I it is, let's say 0, 1, 2, 3, जो भी हमारा I है, let's assume that I actually corresponds to one of the T1 or T2. Okay, in that case, what will be the value of T2? S minus I, right? So we can just get rid of this loop. Okay, so what we need to do is, let's assume if I is R. So our assumption is, assume that I is T1. Okay, without loss of generality you can assume that. So the value of T2 can be similarly find as S minus I, right? This will be T2. But you need to do something, that whether T2 is present in 0 to n or not, that is the condition that you want to meet, right? So what you can do is, you can first check whether S minus I, the second part of the value of T2, or I can just keep a variable here and let me just call it S minus I. Okay, so whether T2 is greater than equals to 0 and n, T2 is less than equals to n, right? If that is the case, that means that basically you have find the corresponding match of I for T2, and both will sum up to S, and there will be only exist one such number, right? So basically we have T2 which is 0 and T2 is less than equals to n. So now what we will do is, we will just take the difference of them and store it in the maximum diff. So we will have maximum of T2 minus I and the maximum diff, right? Okay, now let's run. The output is same, and we have got the rid of the second loop that we had. So earlier it was big of n square, now we are talking about big of n. So just to give you a quick recap, like why we got into TLE. So most of the problem, as I mentioned earlier, right, their sizes, when we were solving earlier, we saw that the size of the problem was very short. So that's why when we didn't apply binary search, or when we didn't apply any sort of a smart trick to actually get it accepted, it was being accepted because the limits were not that big of a deal. But here if you see, the number of test cases are 10 to the power 3 and the value of n is 10 to the power 5, and the sum is basically 2 into 10 to the power 5, right? So if you are going to go for big of n square approach, that means in terms of number you are going to go for 10 to the power 10, and multiplied by the test cases you are going to go for 10 to the power 13. That is basically your roughly that many iterations you will do in your code. So 10 to the power 13 is never going to complete in 0.5 second. You have to sort of get 10 to the power 6 at most, right? 10 to the power 6 or 10 to the power 7 in terms of number to get it accepted. So what we have done here is basically we have the T loop. So this is 10 to the power 3 and n is basically 10 to the power 5. So we are roughly 10 to the power 8, which is okay because we are going for 10 to the power 8 approach. But let's see whether this gives us the TLE or not, right? So we have already run it. We just need to submit it. Yes, it is showing us the correct answer. So 10 to the power 8 works here. Why? Because basically the number of input, although it shouldn't have. Why? Because the test cases were not that big. Here if you have like sort of given me the same value of n every time and the same value of s, let's say 10 to the power 5 and 2 into 10 to the power 5, I might go TLE. Okay, but since this is still small, not a very difficult problem, this is 1254, right? So that's why this is working. But going beyond, you will see TLEs more and more. That will be like basically you will start solving, you will start finding the correct answers, but you will get into TLEs, and that's where the brain thing comes. You will have to optimize your solution. How would you optimize your solution? How well you see the code, right? So let's see this. Basically first question comes is like, since we have got this correct, okay, from TLE to correct, that is fine, but do you think that this code is still optimal? For those who really want to solve this question, that basically this problem can be optimized further, here is the time for you. Pause the video, see the code, see the problem, see the inputs, check where we can improve, check the if conditions, check whether we are doing it something wrong, can it be done faster or not, what is the thing that basically from the problem statement what you can get, right? So here is the time, pause the video and see that. And for those who just want to enjoy the show, here it is. So if you look at T2, this is s minus I, okay, and s minus I is basically, if you are looking at this, what we are trying to find it, I is should be less than so if you try to put this T2 into this if condition, you will see this. So this is s minus I is greater than 0. So basically what we are saying is that I should be less than equals to s. First thing is first, because if I is basically beyond s, then there is no point, because if the I has already gone bigger than s, then you cannot find any pair which has a tastiness which is positive and that adds up to s, right? So that is first thing. Second thing is that we want to check whether s minus I is less than equals to n. So let me just put this here and reorder the variables. So if I take this n here, then n would come as s minus n and I would come in. So now this condition says that I should be less than equals to s, but I should be greater than equals to s minus n. Okay, so the very first I which is going to satisfy this condition, okay, you can actually see this very intuitively as well, that the very first I which is going to satisfy this condition is going to have the maximum, the very first thing, right? So why? Because our difference is t2 minus I, and t2 minus I is basically s minus I only. So this is basically s minus I. So basically we can simplify it a bit, and we can just write it like this. Right. So if you look at this code, now we are basically saying that whatever the very first I which satisfies this condition, because we are going in the increasing order, whatever the first I which satisfies this condition is going to have the maximum. Why? Because you are subtracting 2 into I. So 2 into I would be lesser for the very first I, right? This term would be the least for the very first I which encounters this, which passes this if condition. So in that case, basically you do not have to do anything. You can just break from the loop after outputting s minus 2 into I. So this improves on our best case, right? This improves on our best case and average case a little, not in terms of time complexity. For average case, not in terms of time complexity, but the iteration that this loop will perform. So the number of iteration will, from n you are reducing it down to n by 2 on average, right? For just random numbers of s and n. Yeah. So basically this will give you the correct output. Let's check it. Yes, and still we will be passing this. So this is a very first observation, that the very first I which is going to satisfy this if condition is going to contain the maximum value, right? So basically that is going to have the largest difference, right? Now the second question comes is how we optimize this further. So for those who think that this cannot be optimized, this is the best of its this code is at the best of its nature, no, you are wrong. And those who think that it still can be optimized, yes, you are on the right track. So how can this be optimized further? So if you look at it, this condition s minus n is less than equals to I. So this condition is something that we want to see and analyze. Okay, so we want an I to have just greater than s minus n. So consider two scenarios. Okay, this s value, this s minus n term either can be negative or can be positive. Okay, if s minus n, s is definitely positive because s is given in the description, right? So s is positive, but this s minus n term, this can be either positive or can be negative, right? So in that case, if it is positive, then basically we want the I to be greater than that positive number, right? And the very first I that is going to satisfy this is going to be that number only. So for example, let's say s minus n comes to be 3. Okay, in that case the very first I which can satisfy this is 3, correct? So that is our very first I. Okay, if s minus n is positive, but if s minus n is negative, in that case let's say s is smaller than n, in that case s I, the very first I which satisfies this s minus n greater than I greater than equals to s minus n, that will be 0. So in both the cases, you know the I which is going to satisfy this if condition if given s and n, right? So what we are saying is, if s is less than n, okay, in that case you know that if s is less than n, then basically you know that the very first I which is going to satisfy this is going to be 0. So the first number that you have is 0, and the second number will be then s, because s is definitely less than n, right? So the second number would be s, so the difference will be s only. Okay, else, your s is basically greater than equals to n. In that case, if s is equals to n as well, then also the difference will be the very first I which satisfies this condition is 0, right? So if s is less than equals to n, then basically the very first I is sorted. If s is greater than n, in that case this number is positive. So the very first I which satisfies this condition will be the positive number other than 0, and that will be the same number. So in that case, the very first number that you will get is s minus n. And if you think about carefully, the second number which actually form the sum as the T2 value, the T2 value will be after subtracting this from s, so that will be n, because s minus bracket of s minus n is n, right? So in that case, what we can say is the value will be n and s minus n. So in the second case, the number will be n and s minus n. So what we are trying to do here is basically we are trying to apply mathematical logic, okay, to figure out whether we need to iterate over the loop or not. And this will be required in most of the problems. Okay, you will need to analyze this way, that if s is greater than n, if s is less than n, check around the boundaries of the input. Okay, see if you can find some logic, if you can build some logic, and that logic has to be justifiable, just like in this loop, right? The logic has to be justifiable in terms of your base code as well. It can be derived from your base code as well, right? So let's remove this. So now our problem just boils it down to if and else, right? Now let's run it. This is correct. Correct answer. And as you can see, after removing the loop, we have reduced the time by a huge difference, right? It's not even in 0.5 seconds, we are talking about some milliseconds or something, right? So this is the very optimized solution. And right now the problem is very small, so figuring this out is fine. But later on, as we are going with higher difficulties, there will be some part of the pieces of the code which you will need to optimize separately so that your code can pass. So this is like the first thing that we did. Now we will jump onto the second problem, and we will join after the short break.